Maritime Academy. Air pressure and winds. Atmospheric pressure. Air pressure is simply the mass of air above a given level. Recall, as we go up in the atmosphere, there are fewer molecules above us. Pressure always decreases with height. Pressure equal temperature multiplied by density multiplied by a constant standard atmosphere equal 1013.25 hectopascals, HPA, which is equivalent to 1013.25 millibar, MB, or 29.92 inches of mercury. A simple atmospheric model, a model of the atmosphere where air density remains constant with height. The air pressure at the surface is related to the number of molecules above. When air of the same temperature is stuffed into the column, the surface air pressure rises. When air is removed from the column, the surface pressure falls. All things equal, two columns of air at equal temperature and height. Pressure is approximately equal to temperature multiplied by density. P is pressure, T is temperature, rho is density. Pressures equal but temps different. It takes a shorter column of cold air to exert the same pressure as a taller column of warm air. The difference in height between the two columns is greatly exaggerated. Pressures are the same, temperatures are not the same. P tilde T rho, P tilde T rho. Air flows from a high into a low. Because of this fact, aloft, cold air is associated with low pressure and warm air with high pressure. The pressure differences aloft create a force that causes the air to move from a region of higher pressure toward a region of lower pressure. The removal of air from column 2 causes its surface pressure to drop, whereas the addition of air into column 1 causes its surface pressure to rise. Measuring air pressure, mass of the atmosphere above any level, or the force exerted by the air molecules over a given area. Barometer instrument used to detect and measure pressure changes. Millibar, MB. Unit of pressure, most commonly found on surface weather maps. On thousandth of a bar. Hectopascal, HPA. New preferred unit of pressure on surface maps. 1 MB equal 1 HPA. Inch of mercury, Hg. English unit of measure for pressure. Used on TV quite a bit. Atmospheric pressure in inches of mercury and in millibars. Diurnal pressure changes daily. Sea level pressure variations in middle and low latitudes. Middle latitude pressure changes are primarily the result of large high and low pressure areas that move toward or away from a region. Diurnal surface pressure changes in the tropics reflect the influence of the atmospheric tides. Barometers, barometric pressure, term often applied to atmospheric pressure because it is measured using a barometer. Mercury barometer, Torricelli, 1643, long glass tube filled with mercury. The height of the mercury column is a measure of atmospheric pressure. Aneroid barometer, most common type of home barometer. No fluid, but rather an aneroid cell, small flexible metal box, sealed to outside so when pressure changes the box expands/contracts. Altimeter and barograph are two types of aneroid barometers. A recording barograph pressure reading, station pressure, barometer reading at a particular location, and elevation, altitude corrections must be made so that a barometer reading taken at one elevation can be compared with a reading taken at another site. Near the surface, pressure decreases on the average by about 1 MB for every 10 meters increase in elevation. Sea level pressure, adjusted barometer reading. Size of correction depends on how high station is above sea level. Isobar, lines connecting points of equal pressure. The top diagram A shows 4 cities, a B, C, and D, at varying elevations above sea level, all with different station pressures. The middle diagram B represents sea level pressures of the 4 cities plotted on a sea level chart. The bottom diagram C shows isobars drawn on the chart, gray lines, at intervals of 4 MB. Sea level isobars drawn so that each observation is taken into account. Not all observations are plotted. Sea level isobars after smoothing. Surface and upper air charts, sea level pressure chart, surface map, chart with sea level pressure values plotted on its surface weather map chart. A map that shows the distribution of sea level pressure with isobars and weather phenomena. Surface chart. Because of the changes in air density, a surface of constant pressure, shaded gray area, rises in warm, less dense air and lowers in cold, more dense air. Where the horizontal temperature changes most quickly, the constant pressure surface changes elevation most rapidly. Surface map showing areas of high and low pressure. The solid lines are isobars drawn at 4 MB intervals. The arrows represent wind direction. Surface charts. Winds arrows on a surface map indicate the direction from which the wind is blowing. A fromy. Blue H represent high pressure, or anticyclones. Red L represent low pressure, or mid-latitude cyclones, extratropical cyclones. Isobars, lines of equal pressure. Millibars MB. The 500 MB map for the same day as the surface map. Solid gray lines on the map are contour lines in meters above sea level. Dashed red lines are isotherms in degrees C. Arrows show wind direction. Upper air charts. Upper air charts are charts of equal pressure. Therefore, the heights of these equal pressures vary. Iso heights, contour lines, lines that connect points of equal elevation above sea level. Blue H's are high heights, red L's are low heights, ridges, elongated highs, warm ridges, troughs, troughs, elongated lows, cold troughs. Why the wind blows. Newton's first law: an object at rest will remain at rest, and an object in motion will remain in motion. Travel at a constant velocity along a straight line, as long as no force is exerted on the object, that is thrown baseball. Newton's second law: the force exerted on an object equals its mass times the acceleration produced, F equal m multiplied by a. Why the wind blows. Continue. F equal m multiplied by a. When mass of an object is constant, the force on the object is directly related to the acceleration that is produced. Acceleration is the speeding up, the slowing down, or the changing of direction of an object. Change in velocity over time. More than one force acts on an object, and Newton's second law refers to the net, total force that results. Objects accelerate in the direction of the total force acting on it. Forces that influence the wind. The higher water level creates higher fluid pressure at the bottom of tank A and a net force directed toward the lower fluid pressure at the bottom of tank B. This net force causes water to move from higher pressure toward lower pressure, since it is easier to visualize a tank of water than a tank of gas. Forces that affect the horizontal movement of air. Pressure gradient force, PGF, Coriolis force, CF, centripetal force, friction, pressure gradient, and PGF. The pressure gradient between point 1 and point 2 is 4 MB per 100 kilometers. The net force directed from higher toward lower pressure is the pressure gradient force. Winds always blow from higher toward lower pressure. Pressure gradient equal difference in pressure/distance. Pressure gradient force, the force due to differences in pressure within the atmosphere that causes air to move and hence the wind to blow. directionally proportional to pressure gradient. PGF is directed from higher toward lower pressure at right angles to the isobars. PGF causes the wind to blow. PGF, the closer the spacing of the isobars, the greater the pressure gradient. The greater the pressure gradient, the stronger the pressure gradient force, PGF. The stronger the PGF, the greater the wind speed. The red arrows represent the relative magnitude of the force, which is always directed from higher toward lower pressure. Pressure gradient force surface weather map for 6 a.m. CST, Tuesday, November 10, 1998. Dark gray lines are isobars with units in millibars. The interval between isobars is 4 MB. The distance along the green line XX is 500 km. Wind directions are given by lines that parallel the wind. Wind speeds are indicated by barbs and flags. The solid blue line is a cold front, the solid red line a warm front, and the solid purple line an occluded front. The heavy dashed line is a trough. Coriolis force. If PGF was the only force acting upon air, we would always find winds blowing directly from higher pressure to lower pressure. However, the moment air starts to move from higher pressure to lower pressure, it is deflected to the right in the north hemisphere and to the left in the south hemisphere by the Coriolis force, an apparent force that is due to the rotation of the Earth. As speed of wind increases, deflection due to the Coriolis force increases. Deflection is zero at the equator and a maximum at the poles. Coriolis force summary: objects moving any direction, north, south, east, west, are deflected to the right of their intended path in the north hemisphere and to the left in the south hemisphere. The amount of deflection depends on the rotation of the Earth, the latitude, the object's speed. Coriolis force on non-rotating platform. The thrown ball moves in a straight line. On platform B, which rotates counterclockwise, the ball continues to move in a straight line. However, platform B is rotating while the ball is in flight. Thus, to anyone on platform B, the ball appears to deflect to the right of its intended path, except at the equator. A free-moving object heading either east or west, or any other direction, will appear from the Earth to deviate from its path as the Earth rotates beneath it. The deviation, Coriolis force, is greatest at the poles and decreases to zero at the equator. Straight line flow aloft above the level of friction. Air initially at rest will accelerate until it flows parallel to the isobars at a steady speed, with the pressure gradient force, PGF, balanced by the Coriolis force, CF. Wind blowing under these conditions is called geostrophic. Why is this wind blowing from the west? PT. 1 PGF wind moves toward low-pressure Coriolis, deflects the air to right. As parcel increases speed, deflection increases. PT. 5. The wind speed increases to a point where the CF balances the PGF, net force 0, and the wind blows parallel to isobars. The isobars and contours on an upper-level chart are like the banks along a flowing stream. When they are widely spaced, the flow is weak. When they are narrowly spaced, the flow is stronger. The increase in winds on the chart results in a stronger Coriolis force, CF, which balances a larger pressure gradient force, PGF. Wind flow around low pressure. Winds and related forces around an area of low pressure above the friction level in the northern hemisphere. Notice that the pressure gradient force, PGF, is in red, while the Coriolis force, CF, is in blue. Cyclonic flow around a low. Wind flow around high pressure. Winds and related forces around an area of high pressure above the friction level in the northern hemisphere. Clockwise flow around a high. Anticyclonic flow around a high. Wind flow around highs and lows. Gradient wind that blows at a constant speed parallel to curved isobars above the level of frictional influence. Centripetal force. Centri, center pedal, to push toward. The radial force required to keep an object moving in a circular path, directed toward the center of that curved path. Winds on upper-level charts. Winds tend to parallel the contour lines. Widely spaced contour lines equal light winds. Closely spaced contour lines equal strong winds. Meridional flow, a type of atmospheric circulation pattern in which the north-south component of the wind is dominant. Zonal flow, a pattern in which the east-west component of the wind is dominant. Zonal flow, a pattern in which the east-west component of the wind is dominant. An upper-level 500 MB map showing wind direction, as indicated by lines that parallel the wind. Wind speeds are indicated by barbs and flags. See the green insert. Solid gray lines are contours in meters above sea level. Dashed red lines are isotherms in degrees C. Point out zonal and meridional flow. Surface winds. The effect of surface friction is to slow down the wind so that, near the ground, the wind crosses the isobars and blows toward lower pressure. Note: surface winds do not blow exactly parallel to the isobars. Friction. This phenomenon at the surface produces an inflow of air around a low and an outflow around a high. Aloft, the winds blow parallel to the lines. Southern Hemisphere winds around areas of low and high pressure in the Southern Hemisphere. Notice that at the surface winds blow clockwise and inward around the low, L, counterclockwise and outward around the high, H. Surface weather map showing isobars and winds on a day in December in South America. Bias ballot law in the Northern Hemisphere. If you stand with the wind aloft at your back, lower pressure aloft will be to your left and higher pressure to your right. Bias ballot at the surface. The same relationship holds if, with your back to the surface wind, you turn clockwise about 30 degrees. Winds and vertical air motions. Generally speaking, vertical motions are only about several centimeters per second, or about 1 mile per day. Air rises over a surface low and sinks over a surface high. Why doesn't air over a low rush off into space? Hydrostatic equilibrium, the state of the atmosphere when there is a balance between the vertical pressure gradient force and the downward pull of gravity. Winds and air motions associated with surface highs and lows in the Northern Hemisphere. Measuring and determining wind. Wind is characterized by direction, speed, and gustiness. Wind direction is the direction from which the wind is blowing. Prevailing wind name given to the wind direction most often observed during a given time of day. Prevailing wind in winter in US is northwest and southwest in summer. Houses should have windows facing southwest to provide summertime ventilation and few windows facing northwest, where cold winds come from. An onshore wind blows from water to land, whereas an offshore wind blows from land to water. Wind direction can be expressed in degrees about a circle or as compass points. Flag trees in the high country. Trees standing unprotected from the wind are often sculpted into flag trees. Wind instruments. Wind vane. Old, reliable weather instrument for determining wind direction. Long arrow with tail. Anemometer. Measures wind speed. Aerovane. Sky vane. Instrument used to indicate both wind speed and direction. Winds profiler. A Doppler radar capable of measuring the turbulent eddies that move with the winds. Provides a vertical picture of wind speed and wind direction. The air vane, sky vane. Wind rose. This wind rose represents the percent of time the wind blew from different directions at a given site during the month of January for the past 10 years. The prevailing wind is northwest, and the wind direction of least frequency is northeast. Automated Surface Observing System, ASOS, a wind vane and a cup anemometer. These instruments are part of the ASOS system